In this video, I want to talk about the length of a vector, also known as the norm or the magnitude. And for the length, we denote it by these two vertical bars. So this here is the length of a vector u. And it's defined as the square root of u dot u. In other words, the square root of u1 squared plus u2 squared all the way up to un squared. Let's look at an example of this. Here I have a vector v and I want to find the length of v. The definition of length says take the square root of v dot v. So we have 4 squared plus negative 2 squared plus 3 squared. So that would be 16 plus 4 plus 9, or 29. So the length of this particular vector is the square root of 29. What about multiplying by a scalar? How does multiplying by a scalar change the length? So let's look at the length of CV. And I don't want to have to worry about the square root, so I'm going to go ahead and square this. By definition, this would then be CV dot CV. One of the properties of dot product says I can move scalars in and out, so I'm going to write this as c squared v dot v, which is c squared times the length of v. And then so we can take the square root of both sides. When we do, we have that the length of CV is equal to the absolute value of c times the length of v. You missed a squared here. So multiplying by a scalar changes the length by that amount, or at least the absolute value of that amount. One special type of vector is called a unit vector. And a unit vector has a length of 1. And a lot of times we want to take any vector we have and change it to a unit vector. So let's start with v being a vector in Rn. I'm going to define u to be 1 over the length of v times v. This is going to be a unit vector in the direction of v. So we know it's a unit vector since the length of u, since this 1 over the length of v is a scalar, we have the absolute value of that. It's always positive, so I don't have to worry about the absolute value, times the length of v, and then we can cancel that down to get 1. So we can build unit vectors in the same direction as a given vector by dividing by the length. Here I have a vector v, and I want to find a unit vector in the same direction as v. We need to start by finding the length of v. This is the square root of negative 3 squared plus 2 squared plus the square root of 3 squared. This is the square root of 9 plus 4 plus 3, which is the square root of 16, or 4. So my unit vector u, we divide through by 4. So negative 3 over 4, 2 over 4, or 1/2, and then root 3 over 4. So this would be a unit vector in the same direction as v. Very much related to the idea of length is the idea of distance. So if I have two vectors u and v in Rn, and I want to know the distance between them. The distance between the two vectors u and v is defined as the length of the vector u minus v. So if I subtract these two vectors, then I can take the length of that, and I will have the distance between them. Here I have two vectors, and I want to find the distance between them. The first step is to actually find u minus v. We have 0 minus negative 3 is 3. Negative 2 minus 2 is negative 4. Negative 1 minus 4 is negative 5, and 1 minus 4 is negative 3. We then want to find the length of u minus v, so the length of this new vector. That's the square root of 3 squared plus negative 4 squared plus negative 5 squared plus negative 3 squared. This would be the square root of 9 plus 16 plus 25 plus 9, or the square root of 59. So the distance between u and v is the square root of 59.